Okay, today we're going to talk about linear approximation. The name linear approximation tells exactly what's going on with this. You are using a line to approximate or estimate the value of a function. Okay? So we are going to use a linear approximation, sometimes called a tangent line approximation, to estimate the cube root of -7. Okay, and I'll just write that down here. Tangent line approximation is the same thing. And when we're done with the problem, I'll draw a picture so you can see exactly what's going on the graph and how the tangent line approximates. So there are several different types of linear approximation problems. Here, we're given a specific value we need to estimate. We're going to come up with a decimal approximation for this, or maybe a rational approximation, a fraction. And we're going to use a value that we already know. Okay, so first, I'm going to pick a function to represent this. And I'm going to say f of x is the cube root of x. And what I'm going to do is I'm going to find the equation of the tangent line at a point close to this value. Okay? So just really quickly, we know that the cube root of x looks like this. Okay? And I want to know what is the cube root of x when x is -7. What is this y value? So first of all, we're going to write the equation for a tangent line at that point, and we're going to use the tangent line to approximate. I need a point near that. So I know that f of -8, the cube root of -8 is -2. So there is a point on my graph, -8, -2. And I'm going to find the slope of the tangent line, or the derivative, at that point. So the derivative is 1/3 x to the -2/3. And the derivative at -8, the slope of the tangent line when x is -8, is 1/3 -8 to the -2/3, which is 1/3, well, -8, remember, is -2 cubed, -2 cubed to the -2/3, which means I'm going to have 1/3 -2 to the -2. I'm going to multiply those exponents together. Well, this is going to be 1/3 -1/2 squared, or 1/3 times 1/4, which is 1/12. And that is my slope of the tangent line. When x is -8. So I have two things. I have a point on the graph when x is -8, and I have the slope on the graph when x is -8. And those two things are going to allow me to write the equation of the tangent line. So using my point and my slope, my tangent line in point-slope form is y plus 2 equals 1/12 x plus 8. Okay, so this is my tangent line. So let's go back to the graph. We'll draw it a little bigger so we can really see what's going on. And let's see how this tangent line equation is going to help us estimate the value of the cube root of -7. So I'm going to exaggerate this a bit so it's clearer what's going on. Okay, so here's my graph. I've just got the negative side here of the cube root function. Okay, so really I've just drawn this part of the graph. Okay, and I know that this graph goes through the point -8, -2. -8, -2. Okay? Sorry, we'll just say f of, let's get rid of this, f of x is the cube root of x. So that's the graph we're looking at right here. And I just found the equation of the tangent line right here at this point, which looks like this. So let's say this is my tangent line right there. And what a linear approximation says is this tangent line is really close to the graph at our target value. This tangent line is really close to the graph when x is -7. You can see it's going to be a little bit below the graph. Okay, a little bit below the graph. And so, while it's not going to give us the exact value, it's going to give us an approximation of what the cube root of -7 is, because it's really close to the graph at that point. Okay, so I'm going to plug in -7 to my tangent line equation here, and I get y equals 1/12, this is going to be times 1 minus 2, or 1/12 minus, I'm going to give this a common denominator, and so I'm going to get -23/12. When x is -7, the y value of the tangent line is -23/12. And that gives me an approximation of f of -7, or the cube root of -7 is approximately -23/12. Well, let's get out our calculator and see how close we are. So, -23/12 is, let's see here, -1.916 bar, -1.91666, and so on. Well, let's see how good our approximation is. The -7 to the 1/3, or the cube root of -7 is, look at that, we are pretty close, -1.9129. Okay, so this is our estimate, and this is our actual value. Okay, so there we have linear approximation. Just a couple of other things to note about linear approximation. I said that the tangent line was below the graph here. The tangent line will be below the graph whenever the graph is concave up, right? If you think about what's going on, if I have a graph that's concave up, any tangent line I draw is going to be below the curve, right? All these tangent lines are below the curve. And in that case, where the function is concave up and the tangent line lies below f of x, below the function, then the approximation is an underestimate. My approximation is less than the actual value. If you have a curve that's concave down, then your tangent line is always going to lie above the curve. And for a curve where the tangent line is above the curve, that tangent line approximation is going to be an overestimate because the tangent line is above the curve. All right, linear approximation. Enjoy.